We're going to talk about browser storage. So there are, when you're running your application in the browser, you can obviously save data. You can get user input, but as any application, that data is ephemeral unless you persist it. So once the application stops running, any data that you have or calculated will vanish, and then when that's restarted, you'll start from scratch again. But you might not want to do that. So there are a few ways of persisting data. One is to basically use cookies. So you have the browser save stuff, and then when the client makes a request to the browser, whatever the important data is can be either saved on a cookie, or the cookie can be some kind of reference to data that's saved on the server, and so you can essentially remember user information that way. The HTTP, we'll talk about the HTTP protocol later, but it's stateless. So every interaction is basically, it's like a goldfish. There's no previous memory of any interaction. So I talk to the server has no idea that I talked to it 2 seconds ago. So if I want the server to remember me, then I need to pass it that information on every request. So cookies are mostly for the sake of the server. It's not really for the client, and the client is the browser. So we're going to talk about local storage and session storage, and that is a way to persist data on the client side. So both they're both basically the same thing. There's session storage, which is basically will last until someone closes the tab. And then there's local storage, which will persist even if you close a tab and then reopen it again. But they both basically work the same way. They're key value pairs, and they're both strings. So it's a very basic kind of data persistence. You can of course store like a string representation of JSON and then parse that in your application if you have more complex data structures, but at the end of the day, it's just a string. So it's very easy to interact with, actually. So if you go into your DevTools in the browser, you can check out, if you go to Application tab, you might have to check out over here. We go into the Application tab, and you can see that there are a number of storage formats here. So we're going to worry about local storage and session storage. IndexedDB, this is a more kind of complex, if you have more complex data that you want to save for an application, you can use this, but we don't talk about that in this course actually. And then cookies, which I just mentioned. So we're going to focus on local storage and session storage. So I click here, I can see that there's some stuff, which basically it's empty. My local storage is empty now, and session storage, you can see that it's empty. So I can go here to the console and I can actually add something to my session storage. So if I look on my window object, I don't know if I can find it, but let's do, you have local storage. You have this local storage object that exists on the window. So let's do window.local storage. And we can see that it's empty right now. So we have this local storage. So this is, we saw on Saturday, we used the fetch API. So again, this is an API. It's something that you can use and interact with using JavaScript, but it's not really a part of JavaScript. It comes as part of the browser, and you can just interact with it as an API, application programming interface. You can interact with it in specified ways using JavaScript. And this storage API is the same way. It's not really a part of JavaScript as such. It exists in the browser, and you can interact with it using JavaScript. So we have this local storage object here, and right now it's empty. So there are two methods. We know from classes, we talked about getters and setters, right? So if you have an object, in Python, we don't do this as much as, for example, Java. But you have a property, and then oftentimes the property will be private, meaning you can't directly access it outside of the class. And if you want to access that property, then you create a method called a getter, which will just return whatever that value is. So if I have a class with, let's say, a username property, if I want to access the username, I don't do myClass.username, I do myClass.getUsername. I call a method, and that will return me the username. Setters, so there's getters and setters. Getters will just retrieve the value, return the value. Setters will actually change or update or create the value. So this local storage object follows that basic pattern. So local storage, since I'm, the window object is the, I'm in the window by default, so I don't have to specify the window. Local storage that I can do get item. There's nothing to get, but we'll just do this. So, and if this key does not exist on local storage, and it doesn't, then it will return null. Okay, so let's try setting an item. So local storage dot set item, and set item takes two parameters. The first parameter is the key, which we'll just call key. We'll call it my key. And the second one is the value. And remember, these both have to be strings. So the only data type you can have in the local storage is string. So now I've set these. So let's retrieve my key. So local storage get item my key, and I see that I have my val there. So, and if we go in the developer tools to the application, we go to local storage. Should be able to see this right here. So we have my key is my val. So now this is here, and if I refresh this, it's still there. And since this is local storage, I can even, let me try. Well, we'll play around with this in a second once we have an example application running. But you can actually, in the developer tools, you can change this to something else. And if I go back to the console and try to retrieve, I get this new value. So it, just in terms of like debugging and playing around, you can do that. Obviously, you wouldn't write any code that depended on being able to do that. Okay, so there is local storage. There's also session storage. So session storage, basically the same thing, except it will not persist if you close a tab. And the API works the same way. So session storage dot, we'll do set item. and we'll retrieve it using get item. And we get that. So if we go again, we go into our application and we can check not local storage this time, but the session storage. We have this session key there. So what are some use cases for this? This is basically, I mean, there are a number of different things you could think of, but so one, I guess a couple of things to note, this is not secure. So you wouldn't want to store like a user password or anything sensitive like that here, because this is just, it's just text. It's not encrypted. It's not, there's basically zero security here. So you can store a number of things, and there's, there's a lot more storage as opposed to a cookie. Cookie is a very limited structure in terms of how much you can store. Local storage and session storage, I forget how much, something like 5 or 10 megabytes. It might vary depending on your browser, but so you can store quite a bit of information. So you can do things like user preferences, or if you're writing a game, you can store, progress, things like that. So not anything that the server needs to know about, but just things that are relevant for the particular session that you're in.
So what's the difference between just setting a variable and session storage? Why would I do a session storage?
Yeah, so if you refreshed self, I guess there are a couple reasons. One, you could, maybe the amount of information that you're storing could be easier to access in session storage. But if you refresh the browser, for example, that data would persist in session storage, whereas the application, it would start fresh. So let's take, we'll just look at a couple example applications. So the first one, let me change this. Another thing to note is that this information is tied to, it's basically tied to the URL that you're at. So if I'm running, localhost port 5500, and if I, save some storage here, I can use that. But if I go to a different browser, then that's no longer going to work. So it's the same thing applies to cookies, where you can't just store all kinds of information anywhere, and then anytime you go to a website, any website can access any of that information. So if I get a piece of, I go to example.com and example.com stores something on my local storage, and then I go to google.com, Google doesn't have access to that information. Okay, so here we are. Let me refresh this. Okay, so here we are. We have this application. Let's take a look at the code. So the HTML, we have just a label. This is where you pick your preferred color, and then we have this select menu, and so that's basically it. Fairly simple HTML-wise. Our app.js. So we have this onload, basically our runner. So the first thing we do is call target select. This could have better name. It could be implemented. This could definitely be refactored. But so what we're doing first is grabbing this selector, which is right here. So this selector, and then we're saying that we're gonna add an event listener to it. And the event we're listening to is a change. So if someone chooses something else, so picking one of these is basically a change event. And if that occurs, then we're going to call set background color. And set background color is basically, so we could do this without using local storage, right? You could just grab whatever the user says and then change the background color based on that. The problem is if you do that, once you refresh the page, then that user preference goes away because it was only stored basically in the application while the application is running. If we want to persist that and say, you know, if someone refreshes the page or maybe navigates away, then comes back or whatever, we can use local storage. So the first thing we do is we try to get the user's preferred color. So when you initially load the application, there shouldn't be anything there. Local storage should be empty or undefined. And then but basically we're going to check if that exists. So if this thing exists, meaning a user has already stated a preference for their background color. If it already exists, then we'll just change the CSS. So we'll grab the body and then change the background color. It will make it equal to whatever value we get from local storage. And if we don't already have one, basically we will set that value. So the logic is a little bit convoluted. So when you do this on your own, you can play around with it. But the basic idea is the user is going to come here. User is going to select the color, let's say red. That background color will change, and that change is reflected here in this local storage. And if I refresh this page, it's still a red background. And even if I close this tab and come back, it's still going to be there. And if I choose a different color, choose blue this time, that value is updated here in the key as well as in the application. And again, I can refresh and it stays blue. I can close out of this tab and come back. Should even be able to, yeah, so incognito will not store that, but. So that's the basic idea. I can also, again, this is not secure, so I could just come in here and can change this key, and then when I refresh, the application will pick it up. And so even though even my application doesn't give an option to choose yellow because this key is not secure, and I can just change it in the browser. You can do that. So you wouldn't want to store anything important there.
If you close your whole browser and then reopen it, will that persist, or does the browser itself have to stay open?
It should. Let me do this. Open. If I close my whole browser here. Yeah, so that stays. Yeah, I believe even if I exited out of the Chrome browser, it should still be there. All right, so let's we could try doing it. We'll change this to local. Let's see, local storage, session storage. I'm going to get rid of this. Now we should be in session storage. So I'll change this to orange. And I'll refresh this. It should still be orange. Close out of this, open it again, and it's gone. So if you close out of the tab, your session is over. Are there any questions about that so far?
So you just said that the session only persists through a refresh and not really anything else.
Yeah, so the session will end if you close the tab, basically. Yeah, so it should persist through a refresh. So I change this, refresh. Whereas if we had just stored this not in session storage, but just, you know, in a variable in our code or something, if we refresh the page, it would go away, it would reset. Okay, let's look at another example. So this is you know, maybe the world's worst game. Close that. Okay, close this one too. All right, so we have a game. We just have a couple H tags, current level, and then this will fill in dynamically, and then we just have a button here. So this app, so we'll run this code, set level, and then click handler. So set level. This is going to, first off, grab this H2 ID, so we'll know what level we're in. And we start off at level 0. And then so you start off at level 0, and then you can click a bunch of times, and if you click 10 times, and it goes up to 1, so you level 1, then level 2, level 3, and level 4, and so on. So that's the game. So we'll grab that, that initial placeholder basically, and then we're going to check local storage and see if that's in there. When we first open the application, that should be, delete that. So I refresh this, and the level will be set to 0 if it doesn't exist. Otherwise, if it does exist, then we'll basically grab whatever's in local storage, and we'll set the text content equal to that. So you can save your progress. If you make it to level 4, that's like a save point. And then this check level function. You could just take a minute to look at this, and then someone could tell me a little bit about what kind of function check level is.
It's a setter.
Okay, yeah. So yes, so right here, there's it's calling a setter. Anything else? So what is check level returning?
Function.
Yep. So it's returning a function. And what is this?
It's like an inner persistent variable.
Yeah, exactly. So it's an inner persistent variable. The word for that is a closure. So this function, check level, returns this function. But JavaScript is smart enough to know that this inner function references something outside of its normal scope. So when you call this function and it returns, there's a reference to count that gets saved. So that's called a closure. There's a closure and count is saved, so this can be referred to. So when I call check level initially, which I do here, I call this and it will return this inner function increment. But this inner function increment also has access to this count variable. So then this, what I'm calling level checker, this function basically here increment with the closure. This is the function that I actually call when the event is triggered. So when I click, this inner function here gets called. And because it's a closure, it saves this value. So it's a way of incrementing this value without exposing it to the rest of the code. So I can't directly access this variable anywhere in my code. It's basically a way of creating a private variable here. So I can increment this every time I click, count gets incremented. And if I've clicked 10 times, then I can set the level. And once I set the level, I call this function, which will basically update the display. It'll update the HTML. So one, minor consequence of that, if you're, obviously, we talked about, this is not secure. Like anyone can see this value, anyone can modify it. So you don't want, anything critical in your application to depend on this. But if I change this to level 99, okay, that's good. And if I refresh it, now this changes to level 99. But what happens if I click 10 times? It actually starts over because when I restart my application, this function gets called again. So this basically gets reset to 0. And as I click, I reset the item. So I couldn't start it. I couldn't cheat and then keep going. I could cheat and then stay at one level, but I couldn't cheat and then go from 99 to 100.
So if you get up to like level 3 and then refresh and then try to go up a level, will that bring you back down to 1 again as well?
Yeah, actually, now that I think about it, this is terrible design. So you and
yeah, I was looking at that earlier, going, wait a second, this doesn't actually save anything.
Yeah, so I should have thought about that. That kind of defeats the whole purpose of using local storage. But there you go. I guess I just wanted to show you guys closure again.
So would you fix that by, would one way to fix that be by storing count in local storage as well?
Yeah, you could do that. So yeah, let's see. Try doing. So if we're starting off with 0, maybe we could start at the beginning here. So let's see, where do we need to actually access that? I guess we could just change it here every time we increment it. Let's try this. So we'll try getting it. If it doesn't exist, then we'll set it. So we'll set it to 0. It's got to be a string. Otherwise, we'll say yeah, that should be fine. And we'll set count equals something like that. And then
Do you
And
have
then
to
I'll
convert
change
that
this.
to an int? Do you want to convert that to an int, your count?
Yeah, I think I'd have to do that. So well, in JavaScript, I think it would add and not concatenate, but let's do, I believe this is, we do it. And then let's do local storage dot set item. Let's try that. Yeah, so it's concatenating that. Let me try this. Let's see. So count, yeah, and then I should be able to convert. Oh, I'm converting the wrong thing. Let me convert this. Let's convert it here. So all right, so if I refresh, that persists, that's good. Okay, so if I save this. Yeah, so now that works the way it should. So you can play it. I mean, it's maybe seems like, I don't know if it seems like a complicated idea, but it's very simple to use. I mean, basically you just do set item and get item, and then the rest is kind of logic. Are there any questions about that? Okay, let me